Now the question is, Jasmine wishes to mix two types of foods P and Q in such a way that the vitamin contents of the mixture contains at least 8 units of vitamin and 11 units of vitamin B. First thing. Now, food P costs rupees 60 per kilogram and food Q costs rupees 80 per kilogram. Second thing. Now, food P contains 3 units per kilogram vitamin A and 5 units per kilogram vitamin B, while food Q contains 4 units per kilogram of vitamin A and 2 units per kilogram of vitamin B. Determine the minimum cost of the mixture, formulate the LPP and solve it graphically. Now, I have made here two things, one a table and one a rough sketch for the graph which we are going to make. Now, why I have made a table? Just to make a question more interesting and in the easy way. Now, we can just fill it here in this part. Let this be vitamin A, vitamin B, and this is cost. Cost is in rupees per kilogram and vitamins are in units oblique kilogram. Units oblique kilogram. Okay. Now, food, we are having food P, food Q, and requirements. Units oblique kilograms. Now, what the question says? Now, the question says content of the foods are at least 8 units of vitamin A and 11 units of vitamin B. 8 and 11 here. Vitamin A and vitamin B. Cost is 60 and 80 rupees. 60 and 80. Now, content in the food P is 3 and 5. 3 and 5, and in the food Q is 4 and 2. Now, you can make this type of a table also. So, we can directly make the constants. Now, let us check it now. Solution now. Let Jasmine. Now, she is mixing two types of food, okay. Now, let Jasmine mixes X kilogram of food P and Y kilograms of food Q. Objective function Z is equal to, now Z is for the cost, we are having 60x plus 80y for minimize. Now, subject to the constants. Now, for vitamin A, we are having 3 units in P, 4 units in Q, and this is the requirement. So, what we are having? We are having 3x plus 4y, and it is given at least 3x plus 4y is greater than is equal to 8. Equation number 1, and this is vitamin A constants in food P and Q. One thing. Then we are having 5x plus 2y is greater than is equal to 11. Equation number 2. Vitamin B constant in food P and Q. And obviously we are having x greater than 0, y greater than 0. Third, non-negative, you can write constants or you can write restrictions, non-negative restriction. Now these are the three equations. Okay, so by this table now easily we can move like this. Okay, now bonding the lines from the corresponding in equations, we are having now 3x plus 4y is equal to 8, equation 4, and 5x plus 2y, 5x plus 2y is equal to 11, equation 5. One thing. Okay. Now, point of intersection, solving equation 4 and equation 5 simultaneously, we get point of intersection point B as, when we are solving we are having point B as 2 comma 1 by 2. This is the point of intersection. Now let's plot the equations. First is 3x plus 4y is equal to 8. 3x plus 4y is equal to 8, and second equation is 5x plus 2y is equal to 11. X and y. Okay, so here I have made the graph. Now when we are putting y is equal to 0, we are getting x as 8 upon 3, and when x as 0, y is 2. So we are having 8, this point as 8 upon 3 comma 0, and this point 0 comma 2. Then when we are putting y as 0, we are having x as 11 oblique 5, and when we are putting x as 0, y as when we are putting, yes, y is equal to 0, 11 upon 5. When we are putting x as 0, then 11 upon 2. Okay, so we are having 11 upon 5 and 0. So this part is this one, comma 0 and 0 comma 11 by 2, 0 comma 11 by 2, and point B 2 comma 1 by 2. Okay, so we have plotted the points. Now checking for the shaded part. Okay, point of intersection we have got it. Nice. Now checking for shaded part. Now let's take any two arbitrary points for equation number 2 now. Sorry, for equation number 1. Equation 1. Now for equation 1 we are having put x is equal to 3, y is equal to 3. Now 3 comma put x is equal to 3, y is equal to 3 in equation 1. Now 3 comma 3 satisfies equation 1 and it is 3x plus 4y is greater than 8. Now how it satisfies? If we are putting 3 comma 3, 3 into 3 9 plus 3 into 4 12, 9 plus 12 is 21 and 21 is greater than 8. Okay, so it satisfies. Now 3 comma 3 satisfies equation 1, 3x plus 4y is greater than 8, therefore shade towards 3 comma 3. Now equation 1 we are having 3x plus 4y, so we are having this one as equation A02, okay, this one as 3x plus 4y is equal to 8 and this equation 5x plus 2y is equal to 11. 5x plus 2y is equal to 11. So now we have to shade towards 3 comma 3. Now 3 and 3 obviously it is lying this side. So our shading will be towards this side. Shading will be towards this side. Okay. Now equation 2. Now for equation 2 now we are having, again take the same points, put x is equal to 2, y is equal to 2, 2 comma 2. Now here 5 times 2 is 10, 2 times 2 is 4, 10 plus 4 is 14 and 14 is greater than 11. Okay. So 2 comma 2 satisfies equation 5x plus 2y is greater than is equal to 11. Therefore shade towards 2 comma 2. Okay, or you can write more nice line, you can write it shade towards the region where point 2 comma 2 falls. Okay, so now we are shading now 2 and 2, obviously it will be approximately on this side, so we are going to shade towards this side. Only 2 equations are there, so our shading portion is now okay. One more thing is left, that is, I am sorry, we are left with now x greater than 0, y greater than 0, greater is equal to 0, therefore shade in the first quadrant. Okay. Now x greater than 0, it means this point, y greater than 0 means this point. Okay. So now our shading will be with this, all these equations, the shading is like this. This is the shading part, like this. Now feasible region we are having A, B and C. A, B, C. Corner points with A, 8 by 3 comma 0. With B, point of intersection. Point of intersection it was 2 comma 1 by 2. 2 comma 1 by 2 and C 0 comma 11 by 2. One thing. Now corner points cost z is equal to 60x plus 80y, that is objective function. Okay, now a 8 by 3 comma 0, z is equal to 8 upon 3 into 60 plus 0. Now this is equal to 160. b 2 comma 1 by 2, z is equal to 2 times 60 plus half times 80. Again this is equal to 120 plus 40, it is 160. And c is, we are having 0 comma 11 by 2, 0 plus 80 times 11 by 2, that is 440. Now minimum cost we are having here, that is these two minimum. Minimum cost. Okay. Now reason is unbounded. Z is equal to 160 is the minimum cost at A 8 by 3 comma 0 and B 2 comma 1 by 2, but now what this but means, but the feasible reason is unbounded, therefore we have to check by the inequality it was 60x plus 80y is less than 160, or 3x plus 4y is less than 8 if z has a minimum point or not. So because reason is the unbounded, okay, so be careful when the reason is unbounded, then we have to go for an inequality with the objective function. Okay, so now we are having three x plus 4y plus 4y is less than 8, and bonding line for corresponding inequation is three x plus 4y is equal to 8, and this is equal to equation 4. Same equations are there, 3x plus 4y is equal to 8 and 3x plus 4y is equal to 8. So we can do one more thing here. we are having now on plotting this line on the graph paper. We will be having the same line. Okay, so now we can write it. Resulting open half plane, that is xy, has no common point with 3x plus 4y is less than 8. Therefore, minimum cost of mixture will be rupees 160 attained at all, because we are having two minimum points A and B. Okay, so minimum cost of mixture will be rupees 160 attained at all the points lying on line segment A with 8 by 3 comma 0 and B with 2 comma 1 by 2. Answer. So for the unbounded part, naturally we have to do something extra. Okay, so here the question was.